In a previous video, I used a modified microwave oven transformer as an electrical metal melter. In this video, you'll learn step by step how it was made and what I'm using it for now. In a previous project, I found an old microwave in a dumpster and hacked it open to see what components I could salvage. This power transformer was one of my favorites and got used in many other projects, like high voltage electrical arcs, making a homemade stick welder, and melting metal. In its current condition, the transformer produces a deadly high voltage that's enough to kill a person on contact, but it won't melt metal. To do that, we have to modify the transformer by rewinding the coils. Looking at the sides of this transformer, you can see that these shallow welds are the only thing holding this together. I'm going to use my bench vise to secure this in place, with one end of the welded sides facing up, and try using a hacksaw to cut it open. This is a fairly weak weld, and a hacksaw will work, but a quick buzz with an angle grinder works a lot better. Now that that's ground off, a hammer and chisel can be used to crack the gap and pry the pieces apart. The rest can be removed by hand. With the bottom off, I've got access to the 3 coils of wire wrapped around the core. The top coil is the primary winding, and I want to take very good care of that. So I've wrapped a cloth over my chisel to protect it as I pry up on the winding. It's in there pretty snug, but prying it slowly and gently from both sides gets it to the point where I can put the chisels down and pull it off by hand. These metal shunts can get knocked out now, and amazingly, this is the only form of current limiting this transformer has. The middle coil is junk, and it all comes out. Then to get the secondary coil off, I'm setting it with the coil resting on the jaws of my vise, and then hitting the middle of the core with a rubber hammer until the winding is free. This got pretty beat up, but that's okay because luckily I don't need it. A chisel works great for scraping off any excess paper and glue stuck on the sides, and now we've got ourselves a naked transformer core. You're looking at the E and I sections of the core, and at this point we're ready to reinstall our primary coil. This coil has about 100 turns of insulated copper wire and needs to be replaced gently to avoid damaging it or scraping the wires. That's why I'm using a rubber hammer so I can still get it in nice and tight. Okay, it's looking like it's supposed to, so now we can add a secondary winding made from this thick 2-gauge copper cable. I was lucky and got this from a scrap pile my brother had at work. Looking inside, you can see it's made of stranded copper wire insulated by a thick rubber coating. My brother got me a heavy-duty copper lug and crimped it in place on the end of the cable. Next, he added a little shrink wrap to protect the connection and hit it with a heat gun to shrink it down and finish it off. Alright, so with the cable bent in half, I can move it up next to the transformer and tuck it down into the gaps. The wire is so thick it's a pretty tight fit and probably couldn't be any bigger. I'm pulling one end of the cable back around the transformer, and I decided to switch the positions of these two so that it forms more of an ascending coil. Now I can press the other side into place and the secondary coil is wrapped, as easy as that. The last step is to put this back together. I don't have anything to re-weld the seams I broke apart, so I'm going to try using this 2-part epoxy glue to see if I can make it work. Both the components get mixed equally. Then I'll add the glue to all the exposed surfaces at the top here and find a way to clamp this down. It turns out my bench vise has a gap wide enough to fit the entire assembly, and after double checking the alignment on the connection, I'll cinch it up tight. I'm adding the leftover glue to the gaps on the edges, and everything is looking as expected, so that can be left to set. Okay, it's 2 hours later and our modification is complete. There's actually no physical connection between the 2 coils, yet this will pump out around 800 amps. To bench test the device, I'm carefully hooking clips to both leads of the primary winding and then adding power. Using my multimeter, I'm showing just over 2 volts now, which is a lot lower than the 1000 volts this used to throw out. But instead of putting out 1 amp, now I'm getting closer to 800. What can you do with that many amps? I thought it would be fun to try melting some metal, which you can see this does easily. The metal melts because it's not as conductive as copper wire. It acts like a resistor and heats up from the electrical friction until it reaches its melting point, or until the insulation on the lead wires melt and the system shorts out. Well, not only was this a fun modification, but I found a practical application for it in making a spot welder like this one. The high current can be directed to fuse sheets of metal together at one precise location. Look for how to make that in another project. Well, now you know how to build the metal melter. If you like this video, perhaps you'll like some of my others. Check them out at thekingofrandom.com.